This is the circuit diagram symbol for a voltmeter. And this is the circuit diagram symbol for an ammeter. A voltmeter measures potential difference V measured in volts. And an ammeter measures current I in amperes. A voltmeter has high resistance. We will talk about resistance and resistors in more detail in the following videos. A voltmeter has a high resistance so that it does not draw any or very little, or it draws very little current from the circuit. Remember, its intention is to measure potential difference, not current. So it must draw very little or no current from the circuit. An ammeter, on the other hand, has very low resistance so that it draws the maximum current from the circuit. A voltmeter is always connected in parallel and an ammeter is always connected in series. In this lesson, we will talk about what it means to connect a voltmeter in parallel and what it means to connect an ammeter in series. At the end of this lesson, you will be able to draw a diagram to show how to correctly connect an ammeter to measure the current through a given circuit element. Draw a diagram to show how to correctly connect a voltmeter to measure the potential difference across a given circuit element. Let us have a look at this simple circuit. We have a battery, a light bulb, and a switch S. We want to measure the terminal potential difference of voltage of the battery between these 2 points A and B. To measure potential difference, we use a voltmeter. A voltmeter is connected across the battery because we're trying to measure the potential difference across the battery, that is between points A and B. This connection is parallel. A voltmeter is always connected parallel to whatever circuit element we are trying to measure the potential difference of. In this instance, we are trying to measure the terminal potential difference of the battery, so we will connect the voltmeter in parallel to it. This means that the battery and the voltmeter should be on separate branches or on different branches. So I want you to look. The battery, the switch, and the light bulb are all connected in the same branch. Look at the blue line. They are all connected along that blue line. This means that the light bulb, the switch, and the battery are connected in series. However, the voltmeter is connected on a separate branch. Look at the green line. So the voltmeter is connected on a separate branch across the battery. This means that the voltmeter is connected parallel to the battery. Why do we connect the voltmeter? Why do we connect a voltmeter in parallel? Circuit elements connected in parallel experience the same potential difference. Circuit elements, if you take anything from this lesson, it's this one. Or I'm going to say something also about circuit elements connected in series. But one, circuit elements connected in parallel experience the same potential difference. That is such an important thing. This means that the voltmeter will experience the same potential difference as the battery. Hence, it will measure the potential difference across the battery. Let's say we still had the same circuit. But now we wanted to measure the potential difference across the light bulb between points A and B. This means that we need to connect a voltmeter across the light bulb. We need to connect the voltmeter parallel to the light bulb. A voltmeter is always connected parallel to whatever circuit element we're trying to measure the potential difference of. In this instance, we're trying to measure the potential difference of the light bulb. So we will connect the voltmeter in parallel to the light bulb. Why do we connect a voltmeter in parallel? Because, as I've mentioned, circuit elements connected in parallel experience the same potential difference. This means that the light bulb and the voltmeter will have the same potential difference. Hence, the voltmeter will be able to measure the potential difference across the light bulb between those 2 points A and B. Now let us look at a slightly different scenario. We still have the same electric circuit. However, now we want to measure the current strength through the light bulb. We're no longer interested in the volt, in the potential difference. We just want to determine the current strength. This means that we will connect the ammeter in series with the light bulb. An ammeter is always connected in series in a circuit, always. What does this mean? This means we will connect the ammeter along the same branch as the light bulb. Why? Circuit elements connected in series experience the same current. This is the second important thing that you will take away from your grade 10, and you're going to use it in grade 11 and in grade 12. Circuit elements connected in series have or experience the same current. Now, this means that the ammeter will experience the same current as the light bulb. Hence, the ammeter will be able to measure the current strength through the light bulb. But also note that the battery, the ammeter, the light bulb, and the switch are all actually connected in series because they are connected within the same branch, the blue line. So it means they will experience the same current. We have come to the end of this lesson. We have learned a few important things that I want you to carry or to remember when watching the next few lessons on resistance and resistors. Additionally, I want you to remember these things when you go to grade 11 next year and grade 12 the other year. 1. A voltmeter is always connected in parallel, and a voltmeter has a very high resistance. Circuit elements connected in parallel experience the same voltage. An ammeter is always connected in series and has a very low resistance. Circuit elements connected in series experience the same current. Thank you so much for watching.